All right, gang, today we're taking a look at what's called slope-intercept form. This slope-intercept form gives us a very easy way to graph an equation written in two variables. So let's take a look at what we've got. All linear equations are written in the form y equals mx plus b or y equals b minus mx, where m is the slope and b is the y-intercept. This is called slope-intercept form. Slope is defined as the rise over run, or the change in y over the change in x, which gives the steepest of a line. So a little formula for you, when you're dealing with slope, we could see change in y over change in x, and the symbol triangle means change. So we could write a formula like that if we wanted to. But remember, it's the way you're going up or down over the way we're going right or left. That's what's going to give us the slope. To graph an equation written in slope-intercept form, you're going to first determine the slope and y-intercept. Second, graph the y-intercept on the y-axis. Third, use the slope to locate points above and below the y-intercept. Fourth, use a straight edge to draw the line with arrows on each end. And last, number 5, label the line with the function rule, which is your y equals mx plus b equation. So let's get started. Here we have it. We have graph the following, y equals 1/2 x. So in this equation, there is no b value. And since there's no b value, we don't have a y-intercept. So we can say our y-intercept is 0. And our slope is that 1 over 2. The rise being 1, the run being 2. So we're going to start our graph at the origin since our y-intercept is 0. And then since the slope is 1/2, we're going to go up 1 unit and right 2 units. Again, up 1 unit and right 2 units. Again, up 1 unit and right 2 units until we reach the end of the graph. Then we're going to follow that pattern in the opposite direction. So instead of going up 1 and right 2, we're going to go down 1 and left 2, down 1 and left 2, down 1 and left 2, down 1 and left 2. Then we take our straight edge and draw our line through the points. So all those points are solutions to the equation. They would satisfy the equation if we plugged it in. I can prove that to you. If we look at this point right here, it's 0.21. If I take half of 2, I get 1. If I look at this point right here, that's 6.3, and half of 6 is 3. There are infinitely many points for this line in opposite directions of the graph. If my coordinate plane was larger and much bigger, I would continue to have more solutions. So for example, the point 150 would be a solution because half of 100 is 50. It would be on this line if it was to continue. All right, so now in number 2, now we have a y-intercept of -5. It's negative because of the minus sign, and our slope is still 1/2. So now instead of starting at the origin, we're going to start down at -5, 5 below the origin. And then again, we're going to follow that same slope, up 1 over 2, up 1 over 2, up 1 over 2, until I get to the end of my coordinate plane. And then we follow it in the opposite direction, down 1, left 2, down 1, left 2, down 1, left 2. Again, you should be using a straight edge, so your line should be much straighter than mine. I forgot in the last, we should be labeling it with our function rule. So over here, this would be labeled y equals 1/2 x minus 5. And again, all the points on that line satisfy the equation. So if I take a look at this point right here, this is point 2, -4, and I plug it into my equation, half of 2 is 1, and 1 minus 5 is -4, so it works. And again, this would have infinitely many solutions. It would keep on going in both directions if our coordinate plane was larger. So the point 145 would also be a solution because if I plug in 100, half of 100 is 50, minus 5 is 45. So any point that it satisfies the equation would be on the line. Now, these two lines together, if I were to merge these two graphs, I would have a pair of parallel lines. Remember, parallel lines are lines that never meet, and they have the same slope continuously. Makes sense because in those equations, the slopes are both 1/2. So if our slopes are the same, you have parallel lines. All right, let's take a look at some more examples. Number 3, now we have y equals x. This one almost looks a little scary because there's not that much there. So there's nothing being added or subtracted. So our y-intercept is 0. And our slope is not 0 because that x by itself implies that the slope is 1. So we can think of that as 1 over 1. So now when I go to graph it, again, I'm starting at the origin. And I'm going up 1, right 1, up 1, right 1, up 1, right 1, and so on. Or down 1, left 1 in the opposite direction. Take your straight edge, draw a nice straight line through those points. Arrows on both ends. Label it with the equation y equals x. Now again, I can prove that all these points satisfy that equation. Look at each point. This is 1, 1. This is 3, 3. This is 5, 5. So for every x we graph, we have the exact same y, satisfying the equation y equals x. All right, so let's see what happens with number 4. So now, again, we have a different y-intercept. It's positive 4 because of the plus 4. And our slope, again, there's no number in front of that x. That implies there's 1x, so the slope is 1 over 1. So we start down up at positive 4, not down, 4 above the origin. And we go up 1, right 1, up 1, right 1, up 1, right 1 continuously. Then follow the pattern in the opposite direction. Down 1, left 1, down 1, left 1. Again, take your straight edge, draw your straight line. It should always turn into a straight line. If it's not, you're doing something wrong. Arrows on both ends. Label it with the function rule, y equals x plus 4. All right, so again, I can prove that all those points on this line satisfy the equation. So if I take, for example, this point right here, that's negative 3, positive 1. If I plug in negative 3, that's negative 3 plus 4. I get 1, so that's correct. If I take this point down here, that's negative 6, negative 2. If I plug that in and I do negative 6 plus 4, I do get negative 2. So we are correct. Okay, so just thinking, keep that in mind because any point that satisfies the given equation will lay on the line on a coordinate plane. All right, let's see if we can keep on going. All right, number 5. Oh, now we have some negatives. Okay, so now again, we don't have a y-intercept because nothing's being added or subtracted. So it's 0. But our slope is negative 2, which we can rewrite as negative 2 over 1. So now instead of our graph going uphill from left to right, it's going to go downhill from left to right. So again, we start at the origin, and that negative 2 tells me to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, and the opposite up 2, left 1. Going up makes it positive, but bringing it back left makes it negative again. Up 2, left 1, up 2, left 1, up 2, left 1. Draw with your straight edge. Notice that we're going downhill from left to right. Arrows on both ends. Label with the rule. Don't lose your negative. So now every point on that line will satisfy my equation. So I can pick one. Let's go with negative 2, positive 4. And if I plug in negative 2 times negative 2 is positive 4. So I know that that is a solution to my equation and to the line. All right, so number 6, once again, this looks a little bit different, but keep in mind the number that is not attached to the variable is always the y-intercept. So in this case, the y-intercept is positive 3, but the slope is still negative 2. So we're going to write it as negative 2 over 1. So this time we start at positive 3, and we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, and so on. Or up 2 and left 1, up 2 and left 1. Draw your line straight through those points. Arrows on both ends. Label with the function rule. And again, if I pick any point on this line, it will satisfy that equation. So let's go with this one. It's positive 4, -5. And if I plug in 4 for x, I should get out -5. So if I do 3 minus 2 times 4, that's 3 minus 8. And 3 minus 8, sure enough, is -5. So we've done it correctly. All right, let's see if I keep going with you. Oh, I'm going to do 2 more with you, it looks like. All right, so now I have a fraction as my slope. Again, my y-intercept is 0. Uh-oh. Bring me back to a color. And now my slope is 3/4. So I'm going to start at 0 and go up 3, right 4, up 3, right 4, or the opposite direction, down 3, left 4, down 3, left 4. These points are a lot more spread out. That's okay, but every point on this line is a solution. Arrows on both ends. Label it with the function rule. So for example, this point right here, it would be a solution, and that's at -4, -3. So if I plug in -4, I should get -3. So -4 in for x. Remember my rule, divide by the denominator, multiply by the numerator. -4 divided by 4 is -1 times 3 is -3, so it is a solution. All right, one more, number 8. This time the y-intercept is 1. And the slope is 3/4. So now I start at +1 on the y-axis and go up 3, right 4, up 3, right 4, or in the opposite direction, down 3, left 4, down 3, left 4. Draw your line nice and straight, arrows on both ends. Label it with the function rule. And again, all those points on that line are solutions to the equation. And it's not just the ones on the coordinate plane, it would extend outside of the coordinate plane. So right now, this point right here is a solution. It is 0.87. So let me show you that that works. Again, if I plugged in the 8, 3/4 times 8 is 8 divided by 4, which is 2, times 3 is 6, and 6 plus 1 is 7, so it checks out. I keep on going, you lucky ducks. Eventually, you'll be doing some on your own. So for number 9, now I have -3/2 x. So now, again, my slope is negative. All right, and I don't have a y-intercept, so my y-intercept is 0. And my slope is -3/2. So I'm going to start at 0 on my origin, and I'm going to go down 3, left 2, down 3, left 2, following in the opposite direction, up 3, right 2. Oh, I think I said that all wrong. Hopefully you realize I was saying starting at the origin, down 3, right 2, down 3, right 2, or up 3, left 2, up 3, left 2. Draw your line. Arrows on both ends. Label it with the function rule. It's negative because it's going downhill from left to right. So again, if I pick any point on that line, it will satisfy my equation. For example, this point right here is 4, -6. If I plug that in, I would do -3/2 of 4. 4 divided by 2 is 2. 2 times -3 is -6, so it checks out. All right, here we go. Number 10. So now my y-intercept is +7, and my slope is still -3/2. So if I start at +7, that's way up here, I would go down 3/2, or down 3, right 2, down 3, right 2, down 3, right 2. I cannot go up 3, left 2 because there's not enough space. Draw my line. Arrows on both ends. Label it with the function rule. And again, all the points on that line in the coordinate plane or beyond the coordinate plane would be solutions to that equation. I could choose one. For example, this one right here is 2, 4. If I plug in 7 minus 3 halves of 2, I should get 4. 2 divided by 2 is 1 times 3 is 3, so it's 7 minus 3, which is 4, so it checks out. And again, if I were to merge these two graphs, I would have a pair of parallel lines. Parallel again because they have the same slope. Okay, so now you're going to try the exit tickets. You're not doing any of those problems today on your own, but tomorrow you will. So be ready and prepared to have to graph on your own with tonight's homework and then tomorrow with your groups.